Okay, here we go with another question related to the electrostatic forces generated between charges. In this question, you have three positive particles of equal charge, positive 7 microcoulomb, located at the corner of an equilateral triangle of side 15 centimeter. Calculate the magnitude of the net electrostatic force on the top corner due to the other charges. What I did here is our equilateral triangle. Each side is 15 centimeter, and our target will be the yellow charge here on top. This is the one. This is our target, and we will start calculating how much the total electrostatic force generated by this charge and this charge on this yellow charge. Okay, so first of all, I can say I have here, let's activate the, I have a 15 centimeter distance here and another 15 centimeter distance here. All right, I will call this charge here as Q1. This one will be our Q2. This one here will be our Q3. Now, to start the calculation, we're using Coulomb's law, which is K, Q, Q over the distance squared. Now, to find the force generated on charge 1 because of charge 2, sorry, let's erase this part here, so make it more clear. The force generated on 1 because of 2, we simply say 8.9 10 to the power 9 multiplied by 7 10 to the power minus 6 and all square, because all the charges are equal. And we divide all this on the distance, which is 15 10 to the power minus 2. We have to convert it to meter, and it's a square. Doing the math, that will give us 19.4 Newton. Okay. Now, before we continue with the calculation, let's try to draw the direction of this electrostatic force. So I'll take the green. Now, all charges are positive. So this is a positive charge, and also this one is a positive charge. Now, because they are both positive, the force will be repulsive, and it will be as an extension to the line connecting both forces, both charges, sorry. So that will be the direction of F1, 2, which is repulsive. All right. Now, to find out how much is the force generated on charge 1 because of 3, amazingly, it will be the same value. It's 19.4 Newton. Why? Because it's the same magnitude charge, and it's the same distance between the Q3 and Q1 as Q2 and Q1. So I will have the same magnitude of the electrostatic force. Now let's draw the direction. Once again, I will have all positive charges that will generate a repulsive and will be an extension from our target. Here it is. That's our F1, 3. Okay, cool. Now, this is not the net electrostatic force. We have to analyze our two forces vectors into two components. So let's start with the fact that I have an angle here. I will call it alpha, and I'll call this one beta. And because it's an equilateral triangle, I know this is a total 60 degrees, which means alpha and beta, they will share that 60 degrees equally, 30 degrees. So let's try doing the analysis. analyzing our component, sorry, that will be F1 3 sine alpha, and I will have one here for F1 3 cosine alpha. Okay, let's pick another color for F12. I will have here F12, the force on 1 because of 2 sine beta. Sorry, let's erase this one, make it more clear. That is, should be sine beta. And same here, I will have the same direction as well. Top F1, the force on 1 because of 2 cosine beta. Okay. If we want to try that in more clear, I can do it this way. So this is my charge, the yellow one. It's located here. Now what we said, I will have the force generated by the third charge on 1 with a sine alpha, and also I have opposite to it the force on 1 because of 2 sine beta. Now look at the color. I have two forces went up, two components, and it will be 1, 3 cosine alpha, and also I will have the F1, 2 cosine beta. Okay? Now, because the magnitude of the forces 1 and 3, 1, 2 and 1, 3, F1, 2 equal F1, 3, and alpha equal beta, they both 30 degrees, that's make it really easy to find how much the total electrostatic force in the x-axis. In fact, it will be 0, because simply they will cancel each other. They equal in magnitude, opposite in direction. But for the y-axis, I will have the total force on the y-axis. It will be F1, 3 cosine alpha plus F1, 2 cosine beta. Once again, it's the same magnitude, the same angles as a degree. That can be written as 2 times F1, 3, let's pick, cosine alpha. And when you do the value, you will end with it will give us 33.57 Newton. That will be the net electrostatic force acted on the top corner of our triangle, or the charge on the top corner of that triangle. I hope you find the example useful and the method is clear. Thank you.